All right, we're starting Unit 5, which our first topic is polynomial division. I'm going to break this video into two parts, a long division part and a synthetic division part, and that way if you only want to watch part of it, you can. So today's focus is dividing polynomials. Again, we can divide polynomials using long division or synthetic division. This video will only focus on long division, the ones that look something like this. As a quick vocab reminder, the thing that you want to divide is called the dividend. That's what you start with. The divisor is the number that you're dividing by, and your answer is the quotient. So sometimes it's helpful to know those vocabulary words. And then sometimes you'll have a remainder, and oftentimes that will be reported as a fraction. Like if it was numbers, something like remainder 2 out of the divisor 3, or with polynomials, it will, of course, have some variables in it as well. Okay, so long division with polynomials, it always works. It can work for any polynomials that you're dividing, and it's very, very similar to long division with numbers. And please never do this. You absolutely cannot just reduce a term like that. Doesn't work. If you do that, a kitten dies. So don't be a cat killer. Cats are adorable. Okay, so here's our first one, long division with polynomials. So we set it up very similar to long division with numbers. We want to divide the polynomial f of x. So that goes here, x squared minus 9x minus 10. And we want to divide that by the polynomial g of x. So g of x is our divisor, and it goes here. And just like with numbers, you think about how much it will go into it. So let's refresh in case you didn't do the worksheet that had you refresh on number long division. Let's refresh. If I had 260 and I wanted to divide that by 4, I would think about that 4 and I would look at the beginning here, maybe the 2. Well, 4 doesn't go into 2, so maybe I'll think about 26. 4 goes into 26 6 times, and then you multiply the 6 times 4 to get 24. You subtract that to get 2, and you bring down the 0. And then you think again, how many times will this 4 go into 20? And the answer is 5 times. And then you multiply 5 times 4 is 20, and then you subtract. In this case, we got a remainder of 0. So 260 divided by 4 is 65. We're going to use kind of that same process here. We're thinking about this x plus 1, and we want to know how many times it goes into x squared minus 9x minus 10. Well, I like to just focus on the first term. How many times is x squared going, or x going to x squared? Essentially, you're thinking about what would I multiply that x by to get it to be the same as x squared? And the answer is that I want to multiply this x by another x. So I'll put that x here above where its like term is. And now I multiply. X times x gives me x squared, and x times 1 gives me 1x. This x distributes to both parts when we multiply. And now, if you think about the next step on division with numbers, it's that you subtract. So we're going to subtract those two things. And when we do that, the x squared minus x squared it reduces. There's nothing there. And we have a negative 9x minus 1x, and that's a negative 10x. And just like with other types of division, like with numbers, we'll bring down that next part. So now I have a negative 10x minus 10. And so I go back to thinking really hard about what I want to multiply this x by, this x right here. What do I want to multiply that x by in order to get this negative 10x? Well, the answer would be that I want to multiply by negative 10. So negative 10 times x. Now I'm going to multiply that by both parts. Negative 10 times x is negative 10x. And negative 10 times 1 is negative 10. And then I want to subtract that, subtract both parts. Well, that essentially means we're adding, because if we subtract a negative, that's the same as adding. These two reduce to nothing, and we have 10, negative 10 plus 10, that also reduces to nothing. We have 0 left over. It's a 0 remainder. So our answer is, if we want to divide f of x by g of x, so x squared minus 9x minus 10 divided by x plus 1, the answer is x minus 10. And we have completed our first long division with polynomials. It's a bit intense, but I promise you, keep trying at it and you will totally get the hang of it. What if we do some long division and we have a remainder? On that last one, we did not have a remainder. It was a remainder 0. Well, if I had 7 cookies and wanted to divide them amongst 2 people, they would each get 3 and there would be 1 cookie left over. So sometimes we just say the remainder. Well, 7 divided by 2 is equal to 3 with a remainder of 1. Sometimes we like to report it as a fraction. So 7 divided by 2 equals 3 and 1/2. So the remainder goes over the number that you're dividing by, the divisor. And with numbers, we typically just smush that together as a improper, no, that's a proper fraction, sorry. And but I think it's useful to look at it this other way, as we got our answer of 3 plus we had 1/2, or each person gets 3 cookies plus a 1/2 of a cookie. This is how we'll report our answer with polynomials. Very similar to that. So let's see how it works. So I want to divide 6x to the third plus 11x squared plus 3x plus 4 by the factor 3x plus 1. So it's set up for us here. We start by just looking at that beginning part. What can I multiply that 3x by to get 6x to the third? Well, hopefully you notice that you need 2 factors of x and you need a coefficient 2. So if we multiply this 2x squared times the 3x plus 1, we get 6x to the third plus 2x squared. Don't forget to distribute to both parts here. Now we're going to subtract that, subtract both parts. In the first position, just like we wanted, that reduces to 0. And here we'll have a 9x squared. And I'm going to bring down everything else. So plus 3x plus 4. And now we just repeat that process. What can I multiply that 3x by in order to get, in this time, I'm looking for, a 9x squared. Well, if I want to multiply 3x by something and get a 9x squared, I need to have a 3 coefficient and I need to have an x to get the x squared. So if I multiply that 3x by both parts, I get 9x squared plus 3x. And now we want to subtract that. Both parts subtract. This first one will reduce to 0 just like we wanted. And we have a 3x minus 3x. Well, that one also reduces to 0. But we do have this part here, this 4, we can bring down. And we repeat that process. We think about, what could we times 3x by to get 4? Well, we can't. The 4 doesn't have an x. And the 3 can't be multiplied by a number to get 4. So we're done. It can't go in anymore. So that's our remainder. So when we report our answer, sometimes we would say 2x squared plus 3x remainder 4, but it's a lot more common with polynomials to write it in the remainder in fraction form. So we would say that our solution is, I'll write it down here at the bottom, 2x squared plus 3x plus, we put our remainder over our divisor. Kind of like when you're dividing by 2 and you add a remainder 1, you put that 1 over that 2 that you were dividing by. It works kind of the same. We put our remainder over the top of what we were dividing by. That's some good handwriting right there. Okay, let's try one more of these. We would like to divide f of x by g of x. And I hope you notice I showed you a lot of different ways this could be written. Sometimes you'll see it written like fraction form, that means divide. Sometimes it'll just tell you divide this by this in words, and sometimes you'll see it with the division symbol. Those all mean the same thing. So we want to divide 4x to the fourth plus 3x to the third plus 2x plus 1 by x squared plus x plus 2. So something to be really aware of is that sometimes there are missing terms and you need to have a placeholder for that. So let's write our dividend here, 4x to the fourth plus 3x to the third. But can you see that there are no x squared terms? We need to include a spot for that. Plus 2x plus 1. It's just like the difference between the number 306 and the number 36. That 0 plays a big role. And with the numbers, you literally can't omit it. Sometimes with polynomials, we omit those 0 terms because we don't need them written there. But if you're doing something where you need to hold that place value, you need to include it so that it can hold that spot. So let's finish setting up our division here. We want to divide that whole thing by x squared plus x plus 2. So this one's pretty intense because we are dividing by a quadratic. But it's the same procedure. We're going to look at our first term, which is x squared, and we're going to think about what do I multiply that by to give me a 4x to the fourth. Well, I definitely need a coefficient of 4, and I need 2 more factors of x. So I'm going to put it all the way down here with its like term, 4x squared. And now I'm going to multiply that, and I have to multiply by each. It's just distributing, really. So if I multiply that, I get 4x to the fourth plus 4x to the third plus 8x squared. And you can see now why it was important to have that 0x squared there, because otherwise this 8x squared would be written beneath the 2x, and those are not like terms. And it's really good to keep it lined up with like terms. It'll make your work a lot easier. So we need to subtract that, and we're going to subtract each part. So we get that reduces to 0, 4x to the fourth minus 4x to the fourth. In this second position, we have a 3x to the third, subtract a 4x to the third, so that's a minus 1x to the third. You don't need the 1 there, but I'll leave it for now. And 0x squared minus 8x squared is negative 8x squared. And then I'll go ahead and bring down everything else, just bring it straight down. Essentially, we're adding 0x and 0. Okay, so now we repeat that process, and this time we're thinking about negative 1x to the third, and we're thinking about this x squared, and hopefully you can see that you would want to multiply that by negative 1x. And I'm going to erase my swoopies. I don't typically write those swoopies as I'm doing this process personally. I just, this time as we're at the very beginning of learning this, I just want to show you that you do need to remember that. So this negative 1x multiplies by the x squared. That's a negative 1x to the third. It multiplies by this middle term, an x, so that's a negative 1x squared. And the negative 1x multiplies by 2 for a negative 2x. So if we subtract those, ooh, lots of negatives here. We're subtracting a negative 1x squared. That's the same as adding. That reduces to 0. Here we have a negative 8x squared minus a negative 1. That's the same as adding. So that's a negative 7x squared. This is also the same as adding. Subtract negative 2 is the same as add 2. So that's a 4x, and we'll bring down that 1. And we keep going. We repeat the process. We're looking at that first term, a negative 7x squared and a positive x squared. So we would want to multiply by negative 7 this time. So if we multiply that negative 7 to each and every one of those parts of our divisor, you'll have, let's see, we'll write it in black, negative 7x squared. I'm going to give myself some more space. We're going to have a negative 7x, and we're going to have a negative 14, and we are subtracting all those things, so we're going to end up adding in all of those cases. First term reduces to 0. Second term here is 11x and plus 15. So now we just have to write our answer, except maybe we should pause here and talk about why I know I'm done. I would be thinking about x squared, and that won't go into 11x. Another way to know that you're done and you're at your remainder is that if you line these terms up correctly with their like terms below them, when you reach the end of that, you know you're done. So that's kind of a handy thing to notice as well. So our solution, I'll write it over here, is 4x squared minus x minus 7. And our remainder is an 11x plus 15. And I put that over the divisor, x squared plus x plus 2. Sorry, that got a little cramped. And that is our answer, our full answer. Oftentimes they'll ask you for your answer in the form of q of x plus r of x over sometimes d of x or p of x. And this is that form. If you look at it, you can see that this is my q of x. My r of x is that remainder, and the divisor goes on the bottom. So it's in that form of a polynomial plus a polynomial over a polynomial. Okay, there's a few for you to practice on your notes. I'm going to put the solutions up here so you can look over them and see if you agree with the work. And now you can pause if you need to look over yours. Try this one. Pause if you need to for a minute. And here's the solution. And one more of those. Pause if you need to do it. Try it out, see if you agree with our solution, and here is the solution. And that's it for the long division. I'll make a separate video for the synthetic division. That way, if you only need help with part of it, you can just watch one or the other.